Sans Maths channel. I'm now answering a question from the old C4 textbook. So this is related to the P4 syllabus now. And this is from the old C4 textbook. And this is an integration with parametrics. And it's a very interesting question. Actually, there's a few little points that I want to bring out from this question, which some students have pointed out to me. So I'm going to go through this question. So, when I answered, I was actually answering part C, but actually part B as well has some important points that will help to give you a better understanding of these parametrics. Okay, so now it says the curve C has two arcs as shown, and the equations x equals 3t squared and y equals 2t cubed. So this is a parametric equation, which means that the equation of the curve is defined with three parameters. You have x, y, and you have a third parameter t. All right. So, if you were to, for example, plot a parametric equation graph, like if you wanted to plot this graph, you would have your t value and your x value and your y value. So, for example, when t is 0, you would find x is 0 and y is 0. So that would be referring to this point over here. When t is 1, you find x is 3 and y is 2. Okay, so when t is 1, you'd have a point somewhere over here, 3, 2, for example. Okay, and then when x is 2, when t is 2, sorry, you have x equals 3 times 4, which is 12, and y equals 2 times 8, which is 16, which will be this point here, and so on. So that's how you would plot these points. You could have negative t values, positive t values, and you end up plotting this graph. That's how you would plot a parametric curve if you were to plot one. Okay, now in this question here, we are asked to find an equation of the tangent to the curve C at the point P, where t equals 2. So at the point P, they've told us at this point, t is equal to 2. Okay, so we know the value of t is 2, so we can find the value of x and y as I just illustrated there. So when t equals 2, we can find the coordinates, the Cartesian coordinates of point P. When t equals 2, we know x equals 3 times 2 squared, because x equals 3t squared, which is 3 times 4, which is 12, and y equals 3 times 2 cubed, which is 3 times 8, which is, 2 times 3 cubed, 2 times 2 cubed, okay, 2 times 8, which is 16. So we can say the coordinates of the point P are 12, 16. Okay, so that's the coordinates of the point P, 12, 16. Now, we want to find the equation to the tangent to the curve at the point P. Now the tangent has been drawn here. Okay, it's been drawn for us. This is the tangent. It's a line which touches the curve at point P, but it doesn't cut through it, and it has the same gradient as the curve at point P. So the next thing we need to find is the gradient, okay, at P. The gradient of the tangent at P. Okay, so that's what we have to find. So we have to find basically dy dx. So we got to take our Cartesian, our parametric equation, and find dy dx. Now that is found using the chain rule. So you have dy dx is dy dt times dt dx. Okay, so we got to find dy dt and dx dt. So we got x equals 3t squared. So dx dt is 6t. And we have y equals 2t cubed. So dy dt is equal to 6t squared. So dy dt is 6t squared times dt dx, which is like divided by dx dt. So it's going to be the reciprocal of this. So it's going to be 1 over 6t. So 6t squared times 1 over 6t, that leaves us with just t. So dy dx is equal to t in terms of t. So therefore at P, t equals 2. So therefore, the gradient of the tangent at P is equal to 2. Okay, so we now have the point P, which is 2, 12, 16, and we have the gradient of the tangent at P, which is equal to 2. So we can use y minus y1 equals m times x minus x1. So y minus 16 equals m, which is 12 times x minus 12. 2 times, gradient is 2. 2 times x minus 12. So you have y minus 16 equals 2x minus 24. Therefore, you can say y equals 2x minus 24 plus 16 is 8, minus 8, so negative 8. 2y equals 2x minus 8. That is an equation of the tangent to C at the point P where t equals 2. So this line has equation y equals 2x minus 8, and that kind of looks correct in terms of the shape of the line, the line there. So that seems that we're right there. So here we have part A done. Now for part B, it says the tangent meets the curve again at the point Q. Show that the coordinates of Q are 3 minus 2. Now we know that when t equals 1, well, so when t equals 2, that's one place where the curve touches the line or meets the line, the tangent at point P, and it meets at point Q. So when t equals 2, it meets it, but in fact, it meets it in a special way here. It meets it as a tangent. Okay, and that's something important for us to realize. When something is a tangent to a curve, all right, it has a special type of route when it's a tangent to the curve. So we know now that the coordinates of point P are, let's just write down what we know. Coordinates of point P are 12, 16. And we know at P, t is equal to 2. And we've got to show that the coordinates of Q are 3, negative 2. We've got to show that. This is the Cartesian equation that we're given. Now, we know the equation of our line was y equals 2x minus 8. Y equals 2x minus 8. So how do I find the intersection between this curve and this line? Right, so we should know how to find the intersection between curves and lines by, and this is one of the reasons why I always mention, don't talk about equating them, talk about substituting one of the equations into the other. When you substitute an equation into another equation, you find where those two equations will intersect. Well, those two, the graphs of those equations will intersect. So how do we substitute a parametric equation into a linear equation? Well, we just replace the y with what y is. So instead of y, I'm going to put 2t cubed and replace the x with what x is. So it's going to be equal to 2 times. The x value is 3t squared. And then I've got minus 8. So I've got 2t cubed equals 6t squared minus 8. So I end up with this cubic equation, 2t cubed minus 6t squared plus 8 equals 0. If I solve this equation, I find the places where the curve intersects. Now, you'll see this is a cubic equation, and you'll see that they intersect in 2 places, right? How is it a cubic equation which normally has 3 solutions, yet this intersects at 2 places? Well, what you should understand is when you have a tangent, when the line is a tangent to a curve, at that point, you have what's called a repeated root. So this t equals 2 is a repeated root. So if I want to solve this equation, I could use algebraic division and say t minus 2 is the factor. If t equals 2 is a solution, then one of the factors of this will be t minus 2, and then you'll have a quadratic. How do you find that quadratic? Well, we could go down the road of doing t minus 2, and then we could do our algebraic long division, 2t cubed minus 6t squared plus 0t plus 8, and then we could find a quadratic, could find what you get up here. When you divide them, you should get a remainder of 0, and you'll have a quadratic here, which you then factorize, and you'll end up finding the value of t that you need there. Okay, but what you will find if you do this is that thing when you factorize it, one of the factors will be t minus 2 again. Why? Because you have a repeated root here. When you have a tangent to a curve, there's always a repeated root. So at t equals 2, there's actually going to be a repeated root. So you can say you're going to have t minus 2, again, t minus 2. So you can say you're going to have t minus 2 squared, okay, times something. And here you will have a quadratic. So you can say at squared plus bt plus c. Well, in fact, it'll be linear. Sorry, a linear, not quadratic. It'll be a linear. Why? Because this is a quadratic times a linear. So you can say at plus b equals 0. So we can find the values of a and b here. All right, so let me just expand this and just make it clear. All right, so we know that basically that t minus 2 squared, which is t squared minus 4t plus 4 times something times t plus b has to give us 2t cubed minus 6t squared plus 8. It has to give us that. All right, this is a repeated root. Will give us that when you expand it, and you're going to multiply by something linear. That will give me a cubic. So we can see that t squared times something t gives me 2t cubed. So I know that t squared times 2t will give me 2t cubed. So we can say a must be 2, because this times this gives me that. And we can also look at the last two terms. We can say 4 times b must give me 8. So we can say, therefore, that b is equal to 2. Okay, so we can say the other factor, this factor here, is 2t plus 2. All right, that's the other factor. That means, if you factorize this whole thing, you'll end up with t minus 2 squared times 2t plus 2 is equal to 0. That's going to give me this expression here. So we know this already. This is the other solution when 2t plus 2 equals 0. So 2t equals minus 2. Therefore, t equals negative 1. So t equals negative 1 is what the value of t is at q. So how can we now find the coordinates of q, or show that the coordinates of q are what they asked us to show? Well, we'll take this and we'll replace the t with negative 1. So we see that when t equals negative 1, x equals 3 times minus 1 squared, which is 3, and y equals 2 times negative 1 cubed, which is 2 times minus 1, which is minus 2. So the coordinates of q are 3, negative 2, according to our working, and that's exactly what it is. All right, so important thing here, for us to save some time, instead of doing algebraic long division, we should understand that whenever you have a tangent to a curve, there's a repeated root at that point. So where t equals 2, there's going to be a repeated root. Okay, so we can write that as t minus 2 squared times some linear equals 0, and we can easily find what the values of a and b are, and we can therefore, solve the equation, find what the other value of t is. So t is minus 1 at this point, which is the other place where the curve meets the tangent at p. All right, so there's the answer to part B. Now, part C was actually the part that the students were asking about mostly, so I'm going to now go through that. So here we have the information that we know so far. This is the equation of the line. This is the point P. This is the point Q. Now, they say the shaded region R is bounded by the arcs OP and OQ, OP and OQ of the curve, and the line PQ as shown. So we want to find the area of this shaded region. So we have two parts here. So let's call this region A above the x-axis and B below the x-axis. We know the value of t at P. T is equal to 2 at P. And we know at Q, t is equal to negative 1. We've worked that out so far in our question. So that's important for us. First of all, what I'm going to do is I'm going to think about this shaded region. What I'll do is I'll draw a line from P vertically downwards, and I'll draw a line from this point here vertically upwards until it hits the x-axis. Okay, now what I can do is I can find the area between this point here, which is O, and this point here where t equals 2, and that will give me the area of the curve between the curve up to this point, up to the x-axis. When I integrate this curve between 0 and 2 in terms of t, of our parametric equation, okay, so I'm going to do y dx dt dt. If I integrate up to this point t, okay, it's going to give me the area under the curve up to the x-axis, not below the x-axis, up to the x-axis. That's what that's going to give me. So this is the integral of between 0 and 2 of y, which is 2t cubed times, now we got dx dt, which is 6t, times 6t dt. All right, so when you want to integrate y with respect to x, you want to integrate y with respect to x, but you have a parametric equation, you say the integral of y dx dt dt. Here the limits would be in terms of x. Here the limits will have to be in terms of t. So I'm finding the area under the curve up to this point here. This is the point where x equals 12. This point x equals 12. And this point y equals 16. So I'm going to find the whole of this area between 0 and 12. And then what I'll do, I'll take away the area of this triangle. Okay, I'll take away the area of this triangle. Okay. So this gives me the area under the curve. So I have between 0 and 2. This is going to give me 12. I'll write the 12 outside here. This is t to the power 4 dt. Okay, so that's the area A. Okay, which is going to give me 12. And then I've got my limits. I have t to the power 5 over 5, which is 2 and 0. So I can write this as 12 over 5 times t to the power 5. And my limits are 2 and 0. So this is the integral. I'll keep this integral because I'll need it for that second part as well. But this is going to be 12 over 5 in this case, 12 over 5. And I have 2 to the power 5 minus 0 to the power 5. Okay, so that gives me 32. 12 times 2 to the power is 32 over 5. Okay, so I can find out what that value is. That's the area of the whole of this section. And I know I need to find the area of this triangle. Now, this point is where the graph y equals 2x minus 8 hits the x-axis. So we got y equals 2x minus 8. Hits the x-axis when y is 0. So 2x minus 8 equals 0. So 8 equals 2x. Therefore, x equals 4. So this is the point 4. So this distance is 8. And this distance is 16. Okay, so we can say, let's just work out what this is. So we have 12 times 32 divided by 5. That gives me 384 over 5. I'll leave it like that. I come at 76.8, 76.8. Okay, that's the area of the whole thing. Now the area of the triangle is equal to a half times the base, which is 8, times the height, which is 16. So it's going to be 64. So therefore the area of A, the shaded part A, okay, is going to be, this is like the area of the whole thing. Just leave that for now. The area of the part A is going to be 76.8 minus 64. The whole area minus this triangle give me the shaded region above the x-axis. Okay, so that's going to be what? 76.8 minus 64. That's 76, that's 12.8. 12.8 units squared, right? Just in case, minus 64. 64 over 8, 12.5. 12.8, sorry, units. Okay, so that's the area of part A. Now we need to find the area of part B. Now, if we look at part B, we have basically this first area here. Let me just get rid of that for now. We've got the area over here. And we've got this small triangle. This time, I have to add this area. So let me call this area B. I have to add this area to this area. These two areas have to be added together. So if I find the area under the curve up to the point Q, which is, that's up to 3. The x value of that is 3. And this is 4. So this little triangle here, if we think about it, it has, this is 3, this is 4, that's 1. And it goes down to minus 2, so that's 2. So you can work out the area of this little triangle and add it to the area under the curve between these 2 points. Now at this point, as we said, t equals minus 1, and this point t equals 0. So if I use the same integral, if I integrate the curve, okay, which we had originally here, with respect to t, between 0 and minus 1, okay, between 0 and minus 1. So in this case, I'm going to put the minus 1 here and the 0 there. Okay, if I integrate it, because I know the area is going to be negative, so I'm switching them. Okay, the area is going to be negative because it's underneath the curve. So I'll switch them. Really, the 0 should be here and the minus 1 should be here. Okay, that's how you would normally do it. If the x would be 3, but I'm switching them because I know it's going to be a negative area. So now you're going to have here the integral of y dx dt dt. okay, which will give us the same thing that we found here, which is 12 over 5 t to the power 5, but this time the limits are going to be 0 and minus 1. So I've already done all the integration, but all I have to do is put new limits. This will give me the area which is between the curve and the x-axis, the area underneath the x-axis, between that. If I use this value of 0 and t, it's going to give me that area over here. I use values above the x-axis for t, it will give me the area between the curve and the x-axis, and it will stop there. Okay, that's how parametric integration works. So this is going to give me basically 12 over 5 times 0 to the power 5 minus 1 to the power 5. Okay, so that's going to give me basically 12 over 5. Okay, 12 over 5, which is 2.4. Right? Is that right? 12 over 5, 2.4. Okay, so that's this area over here, and I have to add the area of the triangle. So I've got the area of this little triangle. This triangle here has 2 and 1. So the area of this triangle is going to be a half times the base times the height, which is 1. So I have to add to this. So I've got the area of that other section here, the area of this whole section here, okay, it's going to be basically the area of the curved part plus the area of the triangle. So these two added together is going to be 2.4 plus 1, which is going to be 3.4. So now I have to add that to the original area, which I found, which was 12.8. So I have 12.8 plus 3.4, which gives me 16.2. Okay, so let's just make sure. So we have 12.8 plus 3.4, which gives us 16.2 square units. So there's the answer to that question, right? So basically what we take away from this is if I want to find the area between points in a parametric equation, all right, if the t values are above the x-axis, okay, then you'll find, when you find the area, it will give you the area between those values, between those two limits and the x-axis. And values which are below the x-axis for t will give me the area between those values and the x-axis, but it stops at the x-axis, but they'll be below the x-axis. All right, so that's how that works. Okay, so that's how we can do this parametrically. Some of the students actually found the Cartesian equation and did the integration, and it worked, and it's fine. Okay, and they got the area. Okay, but this is how it works with parametrics. Okay, so that's how you do the parametric integration and get the answer. Okay, so I hope that was clear. Now I'm going to save this this video in a playlist here, but I'll put it for the old P4 or I'll put it under the new P4 textbook. I'll put it in the same playlist as that, but as you can see, it's from the old textbook. This question actually is not in the new textbook, but it's a pretty good question, so that's why I decided to make a video for it. Other questions here about parametrics, I'll put in the playlist over here, and integration in the playlist, in this playlist here. I'll add it to the integration playlist, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.